Okay. So last time we talked about a system that is in equilibrium or is in linear motion, and the condition for a system to be in equilibrium is F net must be equal to 0, or you can say that the acceleration of the system is equal to 0, which means that this can either be the object has a constant v or a v that is 0 at rest. Okay, so this is when the system is in equilibrium. These are the two conditions. And the keywords that we have seen so far is the object is at rest, the object is kept from sliding, the object is in equilibrium. Benda macam tu lah, benda yang make it, that keeps it from moving will be conditions that wants you to solve it in equilibrium. And then we have force that is in linear motion. Oops, sorry. We have force that is in linear motion, which means that we have acceleration. So net forces is equal to ma. This means that your a is not equal to 0 and you are accelerating lah, or the object is accelerating. Now, sometimes you are not accelerating in both the y and the x. No, before I forget, if our net f is equal to 0, this must be satisfied. The net in the fx is equal to 0. The net in the fy is also equal to 0. Remember, f is a vector. Therefore, it can be resolved into its x and y components. So this is what we know about equilibrium condition. When we are in... Sekejap. Ada orang baru masuk kot. Okay, everyone is muted. Jangan lupa sign in attendance. Okay. So then we talked about objects that are accelerating ataupun in linear motion. So the net force is equal to ma, but this does not necessarily mean for both y and x. So maybe this can be net in the fx is equal to ma, but I wouldn't say but lah. And net in the fy is equal to 0. This means that you are either moving to the left or to the right. Sorry, terbalik. Moving to the right or to the left. And you could also be net in the fy is equal to ma. This means you're moving up and down, or just up or just down, boleh mana-mana. And your net in the fx is equal to 0, boleh. And this is still called linear motion walaupun the other component is equal to 0. So this is, you can see this is a positive, negative, and going up is positive and going down is negative. So you have these different conditions, and we have seen systems that is in equilibrium, and the key word is we want to keep it at rest ataupun we want to stop it from moving. We want to stop it from sliding. So those are the keywords that you need to identify in the problem before you start using net f equals to 0 ataupun net f equals to ma. So kena ingat lah kena faham lah basically, not necessarily ingat. Sekejap, my PowerPoint is saving something, I don't know what it is. Cepat. Kenapa ni? Kejap korang. Okay dah. So this is situation number 1, equilibrium. Situation number 2, linear motion, or acceleration is not equal to 0. And then we talked about a bunch of examples. We talked about... Berat sangat ke file ni? Okay. Kita cakap pasal a crate that is released from rest. And we talked about when we have mg, we can resolve it into its mg sine theta, mg cosine theta. You need to know which part gets the angle and which axis gets cosine and stuff like that. You need to resolve mg into its components like this one. And you need to remember that friction always opposes the motion. Your reaction force must be always perpendicular to the surface. And then from here, you have your free body diagram. Determine what is your condition from your problem, and then you write in what is in your axis. For example, our axis is this guy, so you have r minus mg cosine theta, and for your x you have these guys in your x-axis, therefore it's mg sine theta minus f. Again, you start with your condition, lepas tu baru tulis equation yang dalam free body diagram. Okay, and then this problem was slightly harder because they ask you, okay, what is the final velocity? So adalah step-step dia kita dah buat. You can go back to the recording if you like. Okay, so this was the last example that we talked about, which was a lift situation. So let's talk about it balik. So a boy of mass 35 kilograms stands on a weighing machine inside a lift. Like I told you before, a weighing machine actually does not measure your weight. It measures your reaction force. So instead of measuring mg, it's measuring r, because you are actually stepping on the weighing scale. Therefore, ada reaction force, right? When you are pushing the weighing scale, there is a reaction force. That is the force that is measured by the weighing scale. Therefore, if you are on a different planet and you have a different reaction force, or you are accelerating upwards, you have a different reaction force, or you are accelerating downwards, you have a different reaction force, that is what the weighing scale will detect. So don't take your measurement when you are moving, because it's not going to be accurate. You need to be like on the ground and still. Okay, so let's go over this problem again. A boy of mass 35 kilograms stands on a weighing machine inside a lift. What will be the reading of the machine when the lift is accelerating upwards at 2 meters per second squared? So I drew this lift, and I don't remember who this is. Maybe it was, I don't remember who, is it Rafiq? I don't know. So this guy ada mg because that is the gravitational force, and he is standing on a weighing scale, therefore he would have reaction force, and this is about it. And we know that the lift is accelerating upwards. So your free body diagram sebenarnya is just mg and r. There is no friction, he's not moving, he doesn't have the tendency to move. What is moving? The only thing that's moving is the lift. He's inside the lift. Adalah tendensi untuk bergerak-gerak sebab lift tu, adalah kita rasa macam tergerak-gerak sikit kan? Adalah, but I wouldn't call that, macam mana cakap, you're not really moving, you're still in the lift lah. You're not going to the right or to the left. There's no aim, macam like the box on an incline plane. You know that there is gravity pulling it. You are in the lift, there's no one pulling you unless there's a ghost. So anggap je lah tak ada apa-apa. So let's go to this problem balik. Assuming you are alone lah, okay, then you would have that ghost. Okay, so kita ada MA, we know that we are accelerating, therefore we are not in equilibrium. This is not me, this is you guys. So kita start dengan net in the fx equals to 0. Do we have anything in our x-axis? Not really. So actually I don't really need the net in the fx. So we go straight to the net in the fy, which is equal to MA. What mass am I talking about? We are talking about the boy. Even though the lift is accelerating, we want to know what is the reaction force of the boy. So we don't really care about the mass of the lift, we care about the mass of the boy because we want to know the reaction force of the boy. Okay, so this would be the mass of the boy. And this would be the acceleration of the boy. Since he is in the lift, he would accelerate together with the lift. So it would be the acceleration of the lift. So this would be, I don't have space. Kejap, Okay. Kalau soalan, just interrupt me, okay? Right. Let's continue with our example. So m is equal to 35, and in this case, we have acceleration, which is 2. And now you're wondering, doktor, kenapa tak pakai mg? Kenapa tak pakai g? Sabar jap, kita tak siap lagi. So MA is referring to the condition of our We're not in equilibrium, right? So we have to put the A somewhere. So this is where we are putting it. Now we go to our free body diagram. This is our condition. Condition dah settle. Write our free body diagram. Now we put this value over here. Sama macam kita buat untuk equilibrium dulu. So what is in my equation? I have R and mg. So R is positive, mg is minus. So I don't know what R is, but I'm supposed to know what mg is. So that is 35, 9.81, and this would be 70. So 70 plus 35 times 9.81, you would have a reaction force of 35, 9.1 plus 70. We have a reaction force of 413. Hopefully I'm correct. 413.35 Newton. So if the weighing scale detected your weight in kilograms, right? It would divide this by 9.81. Okay, jangan cakap kat sini lah. Kita buat kat tempat lain. This is not part of the equation. So 413.35 divided by 9.81. What will you see on the weighing scale? Let's see. You will find out that you are 42 kilogram, but you are supposed to be 35. So don't weigh yourself when you are accelerating. Okay, that's a bad idea. So that is how you do that one. Now next, okay. The second one is moving down at a constant acceleration. So now it's moving down, the lift is moving down, downwards. It is 2 meters per second squared. Tadi kita going upward. What will happen to our reaction force? It's the same case. But now we have acceleration going downwards. So R, because the boy is on the ground. And then mg, because he has weight. He's not a ghost. So again, F net in the Y is equal to MA. This time our MA is negative. So we need to take note on that. 35 minus 2. Okay, minus 2. So it has a direction, it's going down. So it shouldn't be positive. Now we write in our equation from the free body diagram. Sama just step there. So this is 35. 9.81. I bring this guy over here. I want to make my equation complete. So that is minus 70 plus with 35 times 9.81. So I have my R reaction force is 273.35 Newton. So what will my weighing scale detect? No, not my weighing scale, the boy's weighing scale. So the weighing scale says, hey, you are 27.86 kilogram. So if you want to lose weight, this is how you can do it. Put yourself in the lift, go downwards, measure yourself. Okay? So again, the weighing scale measures your reaction force. Please remember that one. Yang tu saya tak boleh kasih hint dalam exam. Kalau dia tanya pasal weighing scale, memang kena ingat yang ni. The weighing scale measures reaction force. Just solve for reaction force and then itu je lah, solve for reaction force je lah. Okay. Alright. So next one. Ada soalan tak? Before we move on to the next one.
Doktor nak tanya.
Yes.
Kenapa kita kena bahagi jawapan last 10? Kena bahagi dengan 9.8.
Oh, tak payah pun, tak apa. Your final answer is actually just the reaction force. 273.35. Tapi kita punya weighing scale kita measure in kilograms, right? Pemberat. So saya nak bagi tahu je lah. Berat inilah berat budak ni. Sebenarnya berat dia 35. So bila dia accelerating down, berat yang weighing scale tu tunjuk adalah lebih kecil daripada berat dia yang sebenar. Tu je lah.
So, tapi kalau kita punya jawapan last nilai R tu je kita tak bahagi pun dengan yang 9.81 tu tak?
Tak payah.
Oh, tak payah pun tak apa. Okay, thank you doktor.
Unless this would specify in kilograms lah. Okay. Unless, okay. Your answer should be just the reaction force unless they tell you the weighing scale measures in kilogram. Tapi most of the time they measure in kilogram kan. Ada tak yang measure in Newton? I will need to check back on that. But I would accept this lah. You know what you're doing lah, basically. Okay. Okay, next one. A 15 kilogram box is released on a 32 degrees incline. Saya dah penat dah buat pasal incline ni, tapi chapter 3 memang suka incline. So, kena buat lah. Okay, so this is our incline. And it is 32 degrees. Kita tak buat lagi kan soalan ni? Okay. And then it accelerates. Okay, let me draw my box. It's 15 kilograms. Accelerates down at an incline at 0.3 meter per second squared. So this is my A. Find the friction force impeding its motion. So sekarang ni dia memang accelerate Friction force ni impeding its motion ni in a sense that dia slow down the movement ke bawah tu. Dia bukan stop, dia impeding. Impeding tu macam opposing je lah, opposing its motion. So 15 kilogram box is released and accelerates, maksudnya dia tengah bergerak, dia tengah accelerating, but we have friction force that is opposing the motion, not necessarily keeping it from sliding, but just opposing it, causing it to slow down. And then it's asking what is the coefficient of kinetic friction. So here, kalau kita nak go over this problem, we know that we have to solve for friction. And then for B, we know we have to solve for friction yang from A, and we have to equate it to mu R, which means that we have to find R and then friction from part A, and then kita akan dapat our mu. Okay, and kita memang akan solve for kinetic coefficient because it's moving, so it's mu K. Okay, so let's draw our free body diagram. So this is mg. I hope everyone at this point already knows how to draw a free body diagram. R, and then we are accelerating, but we don't know. We have a force, but we are not sure yet. So we have friction back here because our movement is downwards. Okay, and then we need to resolve into our chosen axis. In this case, always choose your axis parallel to the motion. This is your x-axis, and this would be your y-axis. Your y-axis is perpendicular to the motion. Okay, so not resolve pula sekarang ni. Let me use a different color for that. So this is mg sine theta, and this would be theta over here, and this is mg cosine theta. Okay, this is straightforward at this point. Kita dah buat ni banyak kali untuk equilibrium. Perbezaan kat sini ialah, kenapa saya buat bulat di situ? Perbezaan kat sini ialah we have acceleration. Therefore, our net in the fx is not equal to 0. That's the only difference. Your free body diagram is basically the same as an equilibrium problem. So, do not put your acceleration as part of your free body diagram. Free body diagram ni kita start all our forces from the center, right? Acceleration ni is not part of the free body diagram. It's not a force. You just indicate it at the side. Jangan bubur dalam free body diagram Tapi kena ada indication tu so that I know that you know where it's going. Okay? So net in the fx is equal to we have positive mg sine theta and then minus friction. Oh, lupa. I need to start with the condition. I immediately went for the free body diagram. So what is my condition for net in the fx? It is equal to ma. It's not equal to 0. So this guy is equal to 15 times with 0.3. Why is it positive? Because I am assuming this way is positive. Kalau saya nak cakap to the right is negative, boleh juga, but you have to keep it, semua benda yang ke kanan negatif lah. Maksudnya kat sini mg sin theta pun kena negatif. What else? Jadi friction jadi positif. This is if you choose to the right to be negative. You can do that if you want. But let's not make our life harder. So kita akan choose this as positive. Oops. Cubalah untuk memudahkan hidup sendiri ya. So ke kanan adalah positif dan ke atas is positif. So we have positive mg sin theta minus f. And this would be equal to this guy, the condition. This is 15, 0.3. Okay. Remember, first start with your condition, then you write in your equation from your free body diagram. Equate this guy to your condition. Okay, so now kita boleh letaklah kot value-values dia. This guy is 15. This is 9.81. Don't know why this is, okay, betul lah. 9.81 and this is sine 32 minus f. This would be 15 times 0.3. Malas nak kira. 4.5. Okay, 15 times 9.81 times sine 32. So you would get minus 4.5. Would get friction S. I'm bringing friction to here. So this guy minus 4.5. So friction is actually 73.47. And then I'm quite sure ada orang akan datang kat saya kemudian nanti dia tanya, doktor kenapa friction kita tak negatif Okay, kenapa tak negatif? Anyone wants to tell me why? Kenapa jawapan saya positif kat sini? Why is my friction positive? Ini ada kaitan dengan, this is related to what we talked about. Kenapa acceleration dalam linear kinematic, kenapa gravity dan linear kinematic is negative and not here? It's the same reason. So kenapa tak negative? Anyone wants to try? Takut hantu pula. Okay, so tak ada guess. So semua orang macam lost hari ni sebab tengah serabut pasal chemistry kot. Because we have assumed that in free body diagram the friction is negative. So this is Soh Soh punya jawapan. Sophia mesti cakap macam mana nak cakap macam mana. Cuba cerita. So does everyone agree with Soh ataupun ada other theories? Kenapa tak negatif friction kita? Friction kita ke kiri. Why is it not negative? So tak ada. No one wants to guess? Salah pun tak apa kan dalam kelas ni. You don't have to be scared to be wrong. We already know the direction. Feli is saying we already know the direction. Afifah said kalau negatif nanti mu dapat negatif juga. Betul Afifah. So jawapan Soh and Feli betul. Afifah pun betul juga in a different way. So sebenarnya we already indicate the direction in our free body diagram. So apa-apa yang kita dapat kat sini will be positif lah. Okay, because kita dah cakap kat sini negatif. So when I'm solving for friction, I will get the magnitude. This guy already have direction. I already know the direction from this free body diagram. I'm only solving for its magnitude. Tapi kadang-kadang kita akan dapat jawapan acceleration is positive, acceleration is negative. Tu lain sebab dia bukan from the free body diagram. Nanti kita akan tengok pasal ni. So again, I'm going to repeat myself kalau ada orang yang blur kat sini. Okay, dengar. Kenapa friction punya jawapan tak negatif? Because we already indicated in the free body diagram that friction is to the left. Therefore, I already put the negative sign here. So when I'm solving for friction, I'm solving for the magnitude. Sama juga macam, why do I not put G as negative in my free body diagram? Because I put the negative direction in my equation. Sama dah juga macam kenapa saya terletak negative 73 Newton kat sini. Saya tak perlu because the free body diagram already tells me. So I just need to say, okay, friction is 73 Newton. Kenapa PowerPoint nak save pula? Okay, so I just need to label this as 73 and I immediately know from my free body diagram that it is supposed to be negative. The value is 73. When I'm solving it in my equation, I put the negative sign. But when I get the answer, I will get the magnitude. Okay? Sama juga kalau kita solve for, apa lagi? I put mg cosine theta here, I don't put the negative sign walaupun g is a negative, right? I don't say, okay, this guy is negative 20. I don't have to do that. I just put the negative in my equation. Okay, I just need to know what is the value kat sini. The direction is given by my drawing. Okay, so hopefully that is clear for everyone. Jangan confuse kita just fikir free body diagram dah kasih kita direction, jangan pening-pening kepala. Okay, next. So friction is that, harapnya betul lah saya punya calculation kalau ada orang boleh double check please. So that is our friction. Next, friction is equal to mu r. We haven't solved for r yet, so we need to find out what is our r from our net in the Fy. So net in the Fy, this box is not flying. Always ask yourself, is this box flying? It's not. Sorry, it's not flying. So net in the Fy is equal to 0. It's in equilibrium condition. Walaupun X tak equilibrium, tapi Y boleh equilibrium. So this becomes R minus mg cosine theta. And this is equal to 0. This is the equation from your free body diagram. This is the condition, you put it over here. Bolehlah nak terbalik ke apa ke, tapi asalkan korang faham equation dalam free body diagram kena equal to the condition. Nak letak kosong kat sini pun boleh, nak letak kat sini pun boleh. Mana-manalah, tak kisah. It's just an equation. So then your equation becomes R equals to, you bring this guy to the other side. So you have, what is M tadi? 15. 15. This is 9.81 cosine 32. And then R is, jawapan F saya betul tak? Cuba kira sekejap. Cosine 22. 32 silap. This is 32. 124.79. Banyak pula check sekejap. Betul. Okay, thank you semua. Then, so F is, sorry tu bunyi motor kat luar. So 73.48 is our friction. Mu, Afifah cakap kalau kita punya friction negatif, mu kita pun jadi negatif. Betul jugalah. So R kita 124.79. So mu is equal to 73.48 divided by 124.79. So we get our mu K as 0.1. Okay, so coefficient of friction does not have any units, so that's awesome. Just leave it as it is. Do not put Newton. Kalau tak juga rotan diri sendiri. Lepas tu, okay, so let's do a recap on what we have done so far. This problem asks us to find what is the friction impeding its motion. This box is sliding down the incline, right? This box is sliding down the incline and it is accelerating at 0.3. Oh, sorry, saya salah kira 0.59. Feli said it's 0.59. Sorry. 73.48 divided by 124.79. Oh yeah, betul. Saya salah tekan. Kan dia cakap 0.59. Okay, so this is the final answer. Sorry Okay, so kita recap balik apa yang kita dah buat so far. So this box is accelerating downwards, but I just label this as A equals to 0.3. I put a little arrow over here indicating its motion. This is not part of the free body diagram. Let's go over to the free body diagram. We have reaction force is on an inclined plane. Kita ada reaction, kita ada mg. Mg arah dia tak sama dengan axis kita kena resolve into our axis. We have friction. Because it is supposed to oppose the motion, therefore we know this is the direction. Okay, and then we know that this is in our y-axis and this is in our x-axis. So in our x-axis ataupun net in the fx, we know that we have acceleration, therefore it is equal to ma. This is not equal to 0, it's accelerating. This is our condition. So this is 15 times 0.3. Equate this to your FBD. Apa dalam FBD dalam x-axis? Mg sin theta minus F equals to condition. So solve for friction. And then net in the Fy the box is not flying, therefore it's equal to 0. This is your condition. This is your free body diagram. Okay, equate this to your free body diagram. So this is R minus mg cosine theta. Okay, and then you get R. So put in your F equals to mu R, you get your mu. So I think it's easy as long as you understand when to put MA, when to put 0 as the condition. So kena tahulah macam mana nak buat yang tu. And also of course, drawing your free body diagram. Yay, jawapan kita betul. Okay, next. Sempat lagi tak? Okay, sempat. Let's take, do we need a break? No, I can't afford a break right now. Sorry korang, kita tak ada break hari ni. Kita habiskan cepat-cepat, lepas tu we just end class early, okay? So a crate on an inclined plane is connected by a string. Kenapa tak boleh draw pula ni? Okay. Sorry, saya rasa saya cakap laju sikit dari biasa. Okay, saya kena slow down. Sebab saya dapat tidur 2 jam je hari ni. Okay, so this is our inclined plane. Sorry, this is our crate on an inclined plane that is connected by a string. So kita draw our string kejap. Let's draw our string as green. Oh, this is blue, sorry. Over a small frictionless pulley. Okay, so immediately kita tahu it's frictionless, therefore what? Kalau kita tahu dia frictionless ataupun a smooth pulley, what was it? What was it that we need to know about this? Kalau kita cakap pasal small frictionless pulley, okay, basically frictionless lah. What do we know about a frictionless pulley? What is true for this? Okay, I have checked. The tension force sama, betul. That is correct. Thank you, Shaky. So that the tension force on both ends of the pulley ataupun on both ends of the string would be the same. Let's label this as T. So this is your first T, and it says that it is connected by a string over a small frictionless pulley to a free suspended load. Suspended load maksudnya dia tergantung. So this is our load. Agak pelik sikit dia punya ni. Gambar saya ni. So this is our suspended load. If the mass of the crate is 50 kilogram, so we write that 50, let's write mg dulu lah. M1g, where M1 is equal to 50 kilogram and the mass of the load is 40, M2g, this is M2, and this is 40 kilogram. And the inclined plane is 50 degrees. So we draw that over here. What is the acceleration of the system? Oh, sorry, the coefficient, tertinggal info. The coefficient is 0.2. Okay, question. Which way would my system accelerate? Would it accelerate downwards? Would it accelerate to the right or would it accelerate downwards? Do we know? Do we know yet? Or do we not know yet?
Kanan.
Apa dia?
Kanan.
Ke kanan. Ke kanan.
Sebab lagi berat.
Ke kanan. Sebab lagi berat. Okay, kita try dulu. Saya pun tak tahu. So let's label our free body diagram betul-betul. So load number, so this is our M1G, this is our tension force. Ke kanan so we have reaction force here. Korang nampak tak bila dia tengah saving tu? Or,
Nampak.
oh nampak, okay. Saya ingatkan saya seorang je nampak. So and then R, And then we don't know where the friction is, but tadi siapa yang jawab? Shaky ke Amy? Oh, selamat pula yang jawab. Nampak. So she's saying that the system is going to the right, ke kanan. So if the motion is this way, we would say the friction is to the left, right? To try dulu I also don't know. I'm trying to imagine this. So friction, try dulu. And then we have our mg for this guy, m2g, and I would have not reaction, but I would have tension, which is equal to this tension over here because it is a smooth pulley system. This is only true for a smooth system ataupun frictionless pulley. Tension dia akan sama. Kalau you guys advance to degree, nanti bila pakai bila buat pasal forces and the pulley is not smooth, so this doesn't apply. Nantilah, sekarang untuk syllabus kita semua smooth, senang je. Okay, so tension, we are assuming it's going to the right, so friction would be opposing that. Okay, so let's just try it. We don't know really. Okay, apa lagi information kita? A crate on an inclined plane is connected by a string over a small frictionless pulley. The mass of the crate is 50 kilogram. Okay, so another way to draw this would be you can draw your incline like this. Tebal pula. You can draw your incline like this. Boleh, sama je. So this would be mg, and this would be your r. We're just going to go over it. So this would be your tension force connected to a pulley. This would be your tension force connected to your second object. And this would be your M2G. This is your tension. Boleh. And then I'm missing my friction. If we are assuming it's going to the left motion, buat dia sliding down. So kita akan cakap friction is impeding its motion. So it's going to the other side. Okay, so boleh. You will get the same answer even if your inclined plane is like the opposite, is you flip it, right? Sama je. Okay, so now let's write our equation. We know that our net in the Fy is equal to 0 in this case. So that's awesome. Let's solve for M1 first. M1 mass. What time is it? Okay, we have time lagi. So R is equal, 0 is equal to R minus, lupa nak resolve. This would be, this is your theta, mg sine theta, mg cosine theta. Okay, sama je. So R minus mg cosine theta. So you would get R as 59.81 cosine 50. Okay, so that is your R. And then your net in the fx is supposed to be moving, but we don't know where it is moving. Kita tak tahu dia ke kanan atau ke kiri, but we are assuming it's going to the right. We will see if that is correct. So net in the fx is equal to, we are going to say this is positive. Oops, macam X pula. Kita akan cakap ni positive and this is negative. So positive mg sine theta minus with F minus with T. Okay, F kita tahu mu R. Let's try to write that somewhere. Mu R. Comelnya menyanyi. It's Molly. Hi Molly. So 0.2 and R. Whatever that is. Kejap. Penatnya saya patut suruh korang lah buat benda ni. Sebab saya dah buat banyak example dah. Times, but this is a slightly harder problem. Tak boleh suruh pula. Cosine 50. 315.29. And then it becomes awkward and silent. Kita bottom dulu ni. Okay, 315.29. So this would become 0.263.06 Newton. Okay, so this is our friction. Oh, kita sebenarnya ada simple system kat sini. We already know what M2G is because M is given. M is 40 kilograms. Therefore, we would know what our tension is. Okay, let's see. Saya akan skip sikit sorry. Sebab saya nak tengok apa jawapan dia. Saya tak tahu. I'm trying to solve it too. So let's do mass 2. Kejap saya skip. Kita terus pergi kepada mass number 2. Okay. So T, kita tahu it's moving but we don't know which way it's moving. If we are assuming it's going to the right, so I'm going to say okay, the acceleration is going upwards because kalau box ni ke kanan, benda alah ni pun kena ikut lah kan. So dia akan ke atas. So we are going to say the acceleration is going upwards. That is a positive. Okay, saya tiba-tiba bersemangat sebab saya nampak macam ada sinar harapan untuk saya solve ni. Saya pun tak tahu jawapan dia. Sorry guys. Macam itulah hidup So N in the Fy is equal to MA and we don't know what our A is. So this will be our unknown actually. And T minus M2G. Okay, M2G. So T we don't know juga. T minus 49.81. And MA, this refers to M2 sebab this is the system that we're talking about. This would be 40A. Okay. Now, kita akan rewrite T to be 40A plus, tak cukup tempat lah, 40A plus 40 times 9.81. So this is our first equation yang nampak macam ada sinar harapan. Okay, what did I do just now? So I'm talking about mass number 2. Why am I all over the place? I'm talking about mass number 2. This is a mass number 2. So mass number 2, it is also accelerating sebab dia connected to the same string. Therefore, if this box is moving, this guy also needs to move, right? Kalau saya pegang Haikal by a string, saya tak pegang Haikal, saya pegang string, tu Haikal pun pegang string, saya tarik Haikal, Haikal pun kena, saya lari bawa string tu, Haikal kena lari sama dengan saya lah sebab dia pegang string yang sama. Semua juga macam box ni. Box ni is connected to the same string. Kalau this box ke kanan, this guy needs to follow lah. Okay, we're just using our logic here, nothing fancy. So motion to the right, this is what our assumption was, acceleration going upwards. So this is my equation for mass number 2. We don't have to solve with respect to the x. We are solving with respect to the y. X tak ada komponen apa-apa. So net in the Fy is equal to MA. In this case, M is mass number 2. Jangan letak mass number 1. Okay. So this is equal to T and minus M2G. Kita assume going upwards is positive. This is 40A. 40 from mass A, we don't know what that is. T minus 49.81. So we rearrange this equation to become T equals to 40A plus 392.4. 392.4 tepat. So tak ada 2 decimal place. Okay. So back to our mass number 1. So kita kena solve for T so that kita boleh equate these guys together. So let's do that. Kita akan padam ni sebab kita tak perlukan, sama je. Kalau korang nak try boleh try it yourself yang flip version of this free body diagram boleh. So let me rewrite this nicely. 392.4. Sorry Haikal, awak jadi bahan macam biasa Tak kisahkan. 392.4. Okay. Lawak lah. Okay. 392.4. Okay, so that is mass number 2. So the mass number 1, let's go for that. Mass number 1. So net in the Fy equals to 0. Memang dia tak flying lah. So 0 equals to R minus mg cosine theta. So kita dapat yang ni. And then F. Okay, and then we need to solve for net in the Fx. Let me rearrange this kejap. Tertunjuk gambar. Tertunjuk apa nama dia? Solution. Sebentar. Susah pula nak adjust ni. Tak kat sini Okay. And then this guy tak kat bawah. Benda. Okay. Tak kat sini. Okay. Padam. So this is our M1. M1. Apa? M1. Okay. Alright, so next one. Net in the Fx is equal to, kita tahu it's moving somewhere, it's moving to the right. This was our assumption. We said moving to the right is positive, right? So MA, positive. Which M should I use? M1, because I'm talking about M1. Jangan letak M2 kat sini. So M1 is equal to 50. We don't know what our acceleration is. Our condition is 50A. What is in our free body diagram? So we have mg sin theta. Saya lupa pula nak buat arrow dia. Mg sin theta positive minus T minus F. We know what F is. F is supposed to be 63.06. We know what mg sin theta is. Sense stop. M is 50 times 9.81 times apa? Cosine. Times sine. Is everyone following me ke dah macam mengantuk dah? Sekejap sikit lagi. I'm trying to show you guys how to solve this. So 375. 50 times 9.81 times sine of 50. So you get 375. So di berat. Friction is only 63. It's trying to impede the motion. Makes sense. So we need tension lah to cover. Okay, betul. I think the motion is to the right, hopefully. So friction kita 63 je from our reaction force, and our mg sin theta is 375. Betul. 375.74. Benda lah tulis macam ni, tak nampak. Sekejap how should I write this? 375.74. So kalau kita tengok sini logically we know that mg sin theta is 375.74. I don't need to solve this using anything. This is just the value given. So m is 50, g is 9.1, sin theta is given. So sepatutnya saya dah cari dah magnitude dia, siap-siap tadi saya lupa. So friction we solved using mu r, it's 63.06. So nampak tak dia tak balance. Dia tak balance kat sini. So kalau benda ni lagi berat, so motion dia ke kanan lah kan, because the force on the right side is greater than the left side. So yang akan impede motion dia adalah the tension force and the friction force. Friction hanya 63. So tension kena tolong sikit lah kalau tak nak dia accelerate laju sangat. So it makes sense to me that the box is supposed to accelerate to the right. Okay, so I hope everyone is following me. So sekarang kita cuba solve. So mg sin theta apa tadi? 375.74 minus 63 minus 50A. I'm bringing everything over here and I'm bringing the tension to the other side. So it becomes a positive. So this is now 312.74 minus 58. So now we have T, this is the equation, and this is another equation for T. When we have two T's, we know that it is supposed to have the same value. We can equate them together. So this is how we are going to solve it. Okay. Hopefully this is the last step. Tinggal berapa minit je pun. Tak cukup ni. 312. Oh betul-betul. 312. Okay, kalau ada orang lagi laju dari saya, silakan solve 50A. Ya Allah. Okay. So siapa yang rasa dia nampak benda ni membosankan, it is membosankan because it's a bunch of equations. But kita kena tahu juga macam nak buat But it is membosankan, I agree. So this is 90A. Okay, so 312 minus, 312.74 minus 392.4. Aha, so now we get a negative answer. Dun dun dun. What does that mean? So our 8 is 0.88. 0.89, sorry. Okay, korang dapat tak negative sign ni? Did I do my equations wrong ataupun betul?
Dapat juga.
Dapat juga negatif Did you guys try for M2 and M1 semua sekali? Sama tak? Hopefully ada yang rajin and buat sekali. So okay, so from here the acceleration is a negative. What does that mean? Kita assume kita punya direction is to the right, right? So and we said to the right is positive, but the answer that we get is negative. So that means it is going the other way. So this is the beauty of doing a free body diagram and these equations. If your answer is a negative, it means that your assumption for the direction is incorrect. Itu saja. And it's fine if you get this answer, betul. Tak salah pun. Because immediately I know whatever that you draw for your free body diagram, you get this negative. Okay, so your motion is actually the other way. Okay, let's say kita cakap our motion is to the left. Kita tak cakap to the right, kita cakap to the left. Motion kat sini So kita dapat jawapan positif kat sini. Sorry, if you say the motion is to the left, you would get a positive answer for your acceleration. Because you are assuming this way is positive. Tapi susah nak cerita. I think we need to do another example for me to show you the difference. Okay, but basically what it means is, cabut pula saya punya jarum ni. What it means is if you get your acceleration as a negative answer, it means that your assumption for the acceleration punya direction is wrong. But it doesn't mean that your calculation is incorrect. Betul je, your assumption je salah. Assumption salah tak apa Assumption salah. Tapi jalan kira betul. Okay? So I'm going to leave you guys with that thought. A negative answer means your assumption for the motion is wrong, but your calculation is still correct. So let's say you get your answer as positive lah. Anggap kita tak buat motion macam ni Kita still went on with motion to the right. And you get a positive answer. This means that betul. Okay, your system is indeed accelerating to the right. But in this case, we got a negative A, right? So maksudnya, our assumption is wrong. Therefore, our system is accelerating to the left. That is it. Positif negatif tu akan bagi tahu assumption salah ataupun betul. That is it. Okay, that's it for today. Hopefully we can tackle another example similar to this one and wrap up with chapter 3. And all the best for your chemistry quiz, guys. Take care. Bye.
Thank you, Doktor.
Thank you, Doctor.
Bye.
Doctor,
Yeah.
Thank you, Doctor.
for the T for the M2, can we use T equals to A plus 9.1 that we cancel out the M2?
We cancel out the M2. Macam
Yeah,
mana?
for T. T for M2.
Sekejap saya share screen balik. Okay, so T for M2, boleh ke kita cancel out? Dekat mana nak cancel out? Ini?
Oh, dia macam tak boleh kan?
Tak boleh cancel out. Yang ni 48.
sebab dia
So you
Okay.
ikut T with T. Okay?
boleh.
Alright.
Thank you, Doctor.
Welcome.
Thank
Bye-bye.
you, Doktor.
Ya doktor.
Bye. All the best.
Betul.